Question 16. A monoacid organic base gave the following results on analysis. First, 0.10 gram of the base gave 0.2882 gram of carbon dioxide and 0.0756 gram of H2O. Second, 0.20 gram of the base produced 21.8 milliliter of nitrogen at 15 degrees centigrade and 760 millimeter pressure. Third, 0.40 gram of the platinichloride left 0.125 gram of platinum. Calculate the molecular formula of the base. Now, first find out the molecular weight of the base. Now it is given that 0.40 gram of the platinichloride left 0.125 gram of platinum. तो मान लेते हैं कि बेस है B. It reacts with H2PtCl6, which is the acid, to form the platinichloride, which has the formula B2H2PtCl6, and this gives platinum. Now weight of platinichloride is given as 0.40 gram. Weight of platinum is 0.125 gram. Now applying principle of atom conservation for platinum atoms. 1 mole of platinichloride contains 1 mole of platinum. So moles of platinichloride is equal to moles of platinum. What will be the moles of platinichloride? Moles of platinichloride will be equal to weight of platinichloride, that is 0.40 gram, divided by molecular weight of platinichloride, let it be X, and this is equal to moles of platinum, which will be equal to 0.125 divided by atomic weight of platinum, which is 195. सॉल्व करेंगे, सॉल्व करने पर molecular weight of platinichloride आ जाएगा. So molecular weight of platinichloride, that is X, will be equal to 624. So this is the molecular weight of B2H2PtCl6 and this is equal to 624. अब अगर हम molecular weight of B2H2PtCl6 में से molecular weight of H2PtCl6 subtract कर दें, तो we will get the weight of 2 moles of B. And dividing the weight of 2 moles of B by 2, we get the molecular weight of B. So we can write molecular weight of B will be equal to weight of the platinichloride, that is 624, minus molecular weight of H2PtCl6, which is 410. So this will give the weight of 2 moles of B. So dividing this by 2 will give the weight of 1 mole of B or the molecular weight of B. And this is equal to 107. So we know the molecular weight of B or the base. Now moles of carbon is equal to moles of carbon dioxide, and this will be equal to weight of carbon dioxide given as 0.2882 divided by molecular weight of carbon dioxide, that is 44. So moles of carbon will be equal to 0.2882 divided by 44 and this is equal to 0.0065 moles. Similarly, moles of hydrogen will be equal to 2 into moles of H2O and this is equal to 2 into 0.0756 divided by 18. 0.0756 is the weight of H2O and 18 is the molecular weight of H2O and this is equal to 0.0084 moles. Now moles of nitrogen. Now this is the moles of carbon and moles of hydrogen in 0.1 gram of the base. Now this is the moles of carbon and moles of hydrogen in 0.1 gram of the base. Now moles of nitrogen. For moles of nitrogen, first of all we need to find the volume of nitrogen at normal temperature and pressure or under standard temperature and pressure conditions. For that we will use the formula P1V1 by T1 is equal to P2V2 by T2. Here P1, V1 and T1 represent the standard conditions of pressure, volume and temperature. P2, V2 and T2 represent the given pressure, volume and temperature. So given pressure is 760 millimeter of mercury, volume is 21.8 milliliter, temperature is 15 degrees centigrade or 288 Kelvin. Putting the values of P2, V2 and T2, and value of P1 will be 760 millimeter of mercury, T1 will be 273 Kelvin. The value of V1 is equal to 20.66 milliliter. Now moles of nitrogen gas will be equal to volume of nitrogen, that is 20.66 milliliter, divided by molar volume, that is 22400 milliliter. So this is the moles of nitrogen, and moles of nitrogen atoms will be equal to 2 into moles of nitrogen. So this is equal to 2 into 20.66 divided by 22,400 milliliter, and this is equal to 0.0018 moles. Now this is the moles of nitrogen in 0.2 gram of the base. So moles of nitrogen in 0.2 gram of the base, the moles of nitrogen is 0.0018. Therefore, in 0.1 gram of the base, the moles of nitrogen will be equal to 0.0018 divided by 0.2 into 0.1, and this is equal to 0.0009 moles. 0.0009 moles. Now the ratio of carbon is to hydrogen is to nitrogen is equal to 0.0065 is to 0.0084 is to 0.0009, and dividing all this by 0.0009, we get the simplest ratio, that is 7:9:1. So the empirical formula of the base is C7H9N, and the empirical formula weight of the base will be equal to 7 into atomic weight of carbon, that is 12, plus 9 into atomic weight of hydrogen, that is 1, plus 14, and this is equal to 107. Now molecular weight of the base is also 107. अब क्योंकि empirical formula weight और molecular formula weight दोनों same हैं, तो empirical formula और molecular formula भी same होंगे. So the molecular formula of the base will be equal to C7H9N. मॉलिक्यूलर फार्मूला और इंपिरिकल फार्मूला दोनों सेम होंगे. Both empirical formula and molecular formula will be same.